2004 with results. This is chapter 13, where we are right now, example. And I really like this one, and I finally realized I need to stop opening that other data set because something happened to that other baseball. I don't know what happened to it, but I did something. And that's why we were getting results last time that I didn't really like. This is the data set I wanted to be using. So it's posted right here in Minitab for you. So you can go here and you can open this data set up and you can play with it. You can practice, see if you're getting the same results I'm getting as we discussed it in class. And in fact, I posted a PDF here with some results, and I talk about the important numbers in there and stuff like that. So I think if you'll use this spreadsheet and this PDF, I think it will help explain what's going on in Minitab to you. Now, it doesn't explain how to make Minitab do the regression, but I think we're okay on that. But that's what I'm going to start with tonight, that Baseball 2004 data set that's posted in Minitab for you. So here I have information as we've looked at variations on this data set already. I've got all 30 baseball teams, and I've got lots of information on these 30 baseball teams. Now, this data is fairly old. It's 2004. I have a 2015 data set, but the results aren't as nice as this one, so I keep using this one. So we're going to keep using this one. So let's say back in 2004, we wanted to ask that question, which we've already asked a couple of times, but let's do it one more time. Repetition doesn't hurt on this stuff. We want to investigate the effect of team salary on team winning. So we want to know, is there a relationship between how much a team spends on its players and how many games they win? And we would expect that there is a relationship there, right? What would you expect the relationship to look like?
More money, more wins.
Spend more, you win more. The assumption being if you spend more, you're probably going to have better players, thus you'll win more games. But let's see if we can test this using regression analysis. And I know we've done this a couple of times, but I want to walk through this one more time and talk about those unusual observations. So if I want Minitab to do this for me, where am I going to start? Stats, regression, get regression model. And so I get my usual little dialog box here. Now the investigation I'm doing, what is going to be my response? Wins. What I'm trying to explain or predict that goes in the response. So that would be wins. And what am I going to use to predict or explain wins? Team salary. So wins and salary. Click OK.
Results.
The results. Remember the weird table thing there? Results. Change those to basic. Then click OK. Then click OK. And Minitab gives me this nice output here, which I'm going to run again so I can scroll a little bit better. All right. So let's walk through this kind of as an overall analysis. First thing I always want to look at is the regression equation. And the first question I ask about the regression equation almost always, is it a positive or a negative sign on my slope? And in this case, it is positive, which suggests, which means, Hunter, you said it pretty eloquently earlier, didn't you?
No.
You didn't? I'm sorry. Someone said more money, more wins.
Oh yeah, I did say that.
I thought it was you. Don't make me doubt myself already. We have a positive slope here, so that suggests what we thought. You know, the more they spend, the more they're going to win. The coefficient itself is the, well, I keep saying it's the most important. There's like 3 most important numbers, so that's one of them. The actual slope coefficient, 0.23, let's say. So what does that mean? The slope is 0.23.
For every $0.23 you spend, you get another win?
No.
The
Other way around. For every dollar you spend, you get that much win.
Okay, every time X salary increases by 1, Y wins will go up 0.23. Now, salary here is in millions of dollars, so that means every time your team payroll goes up by 1 million, because it's measured in millions, wins will go up, I predict wins will go up 0.23. So if your team spends $1 more million than my team does, you're gonna win 0.23 more games than my team. About a quarter of a game, a fifth or a quarter of a game per $1 million. What if your team spends $2 million more than my team? Then you'll win 2 of those, about 0.46 more games than my team does. That's the slope. It tells me how much wins change when salary goes up by 1. Same way with every slope coefficient. If I told you my team had a payroll of $150 million, could you predict their wins?
It's gonna win a couple of times.
Maybe.
I mean, multiply by 100, right? And whatever it
You
is.
plug in 150 for salary, because again, the numbers are in millions. You wouldn't plug in 150 million, you plug in 150, multiply that by 0.22, and you would add 65 to that. Now, Kim, you asked, I think last time, the adding versus subtracting, it's just whether your intercept term is positive or negative, right? And in this case, the intercept term is positive, so you would add 65 to whatever you put here. Lisa?
So if it had been negative, it would mean more money, less wins.
Mhm. Yeah, if the slope is negative, that would mean the more we spend, the less we win. Which would be surprising, but that's what the slope would mean. All right, so we're okay with that part. Talking about what this equation means, plugging in a value and predicting a result. All right. All right. What else want to talk about here? Oh, let's talk about R squared. Now again, I warned you, and I don't know, some years I do this, some years I don't do this. Some years I will give you output like this, but not give you R squared. Now, as we talked about last class, we have a formula for R squared. It's sum of squares regression divided by sum of squares total. Well, given all this output up here, if you didn't have R squared, could you compute it? You would need to find sum of squares regression. Where would you find that?
It's an analysis.
In the analysis of variance table, in the sum of squares column. Sum of squares regression in this case is 1567, sum of squares total 53, so you would divide 1567 by 5322, and you would get 0.29 whatever. Minitab gives it to us in percent. When we calculate, it's usually decimal. But y'all can handle that, right?
Say it again.
Well, it's sum of squares regression divided by sum of squares total. And that will be on your formula sheet. So, if you have to compute R squared, look at the formula sheet and it will tell you sum of squares regression divided by sum of squares total, and you just need to pull those two numbers out of the analysis of variance table and divide.
So I'm getting the feeling this is one of those years you don't give it to us.
I don't know. I haven't made your test out, but these are some things from years past that I've asked and done. After you compute this number, you need to be able to talk about that number. So the fact that R squared is about 30%, what does that mean for this model?
Doesn't that mean about 30% of it is explained?
All right, we're on the right track there. 30% of what? Variation in wins can be explained by variation in team salaries. So looking at the differences in team salaries can explain about 30% of the differences in team wins. Is 30% a lot? I don't know. I mean, by itself, that number doesn't tell me, is this a good model? This would let me compare a model with salary in it to a model with number of home runs in it. I could compare those two models using R squared, but I can't use that to say if this is a good model or not. If I want to determine if this model is significant, or if this predictor, is team payroll a significant predictor of team wins? That's really the kind of follow-up question I need to ask. And that's kind of what we were talking about over here. For this model,